Okay, so the next topic is looking at sequences and series. So the first thing we have a look at in this question, it says on John's 10th birthday, the first of an annual birthday gift. So therefore the 10th birthday equals the first term. So birthday in terms of the 11th birthday will be the second, the 12th birthday will be the third. So it says, for question A, show that immediately after his 12th birthday, the total of these gifts was £225. It's only worth 1 mark, so it's not going to be that much work. So the 10th is going to be £60, £15 more than the year before. So the next one's going to be £75. The next one's going to go up by another £15, so it's going to be 90. So if we add those together, that's going to be £225. So that's the first easy mark. Find the amount that John received from his uncle as a birthday gift on his 18th birthday. So we're looking for a given term, or a certain term here. So if we're looking for a certain term, it's going to be a plus n minus 1 d. That's how to find any term. Now the first one that we're, so it's a, it's going to be 60, because that's the first amount, so it's going to be 60 plus n minus 1. Now n in this question is going to be the trickiest part. This is 18th birthday. If we have a look here, to get from the birthday to the term, take away 9. So take away 9, take away 9. So the 18th birthday is going to be the 9th term. So if we're going to use a plus n minus 1d, it's going to be 60 plus 9 minus 1, what's the difference, which is 15. So that equals 60 plus 8 times 15, which is 120. So it's 60 plus 120, which equals £180. Question C, find the total of these birthday gifts that John had received from his uncle up to and including his 21st birthday. So 21st, if we take away 9, we're going to get 12. So it's going to be the first 12 terms. If we were looking for the total of a series is n over 2, 2a plus n minus 1, also d. So that's going to be, if we're using n as 12, it's going to be 12 over 2. Lots of 2a, so that's going to be 2 lots of 60, plus 12 minus 1, what's the difference, which is 15. Then it's just a matter of working it out. So it's going to be 6 lots of 120. 12 take away 1 is 11. 11 lots of 15, it's going to be 165. So it's going to be 6 times by 185. So 6 times 185. 6 5s are 30. 6 8s are 48, plus 3 is 51. 6 1s, so it's 285. Come on, score ahead in the game. Let's try that again. So 6 times 285. So 6 5s are 30. 6 8 is 48, plus the 1 is going to be 51. 6 lots of 2 is 12, plus 5 is 17. So 17 10, so it's going to be 1,710. Okay, next. When John had received n of these birthday gifts, the total money he had received from these gifts was 3,375. Show that n squared plus 7n equals 25 times 18. So, if we do that, again, we're going to use the sum of a series. So, sum of n equals n over 2, 2a plus n minus 1, lots of d. So that's going to be 3,375. And it's n, which we don't know, over 2. 2 lots of a. We know that a is still 60, so that's going to be 120. Plus n minus 1. What's the difference, which is 15. So then, if we multiply both sides by 2, that's going to be 6,750. And then we're going to multiply, well, if we simplify the brackets, 120 plus 15n minus 15. So 6,750. 120 take away 15 is going to be 105. So that's going to, if we then multiply that by n, it's going to be 105n. Multiply n by 15n, that's going to be plus 15n squared. So if we divide both sides by 15, we're going to have n squared 105 divided by 15. So n squared, so 105 divided by 15 is going to be 7, so it's going to be plus 7n. Then 6,750 divided by 15. I mean, we're A-level mathematicians. We shouldn't be afraid of doing this here. So 15's into 67 go 4 times with 7 left over. 15's into 75 go 15, 30, 45, 60, 75. So it goes in there 5 times with no remainder. 15's into 0 goes 0 times. So that equals 450, which almost looks like what we've got here. But then we've got to make sure that 25 times 18 is 450. So if we do 25 into 450, 25s into 4 don't go, 25s into 45 go once, with 20 left over, 25s into 200 go 8 times. So you get 25 times 18 is 450, so we can write out n squared plus 7n equals 25 times by 18. And there you go, we've got our 3 marks. Finally, find the value of n. So we've now got to solve this. So if we use this equation here, n squared plus 7n minus 450 equals 0, then we've got to somehow factorize that. So it's going to be n. We've got to find 2 numbers that multiply together to make 450 with a difference of 7. Now here, 25 times 18 equals 450. So 25, 18, and we want to make plus 7n, so that's going to be plus 25 and minus 18. The 2 solutions are n equals minus 25, n equals 18. Bear in mind that n is the number of, is the term of the sequence. We can't have a minus 25th term, so it's not going to be that one. So it's going to be the 18th term. And to get from the term to the birthday, you need to add 9. So if we add 9 onto that, that's going to be 27. So it's going to be John's 27th birthday. So quite a complicated question, that one. But it's worth a lot of marks. So now, if we have a look at the next question, 2015. Okay, so 2015. Again, it's very, very similar. So it's only 7 marks, this one. So just started to work 20 years ago. In year 1, her annual salary was 17,000. So we can see that A equals 17,000. And then her annual salary was increased by 1,500 each year. So I'd write down D equals 1,500. And it carried on until it got up to a maximum of 32,000 in year K. And then it stayed at 32,000. So we've got to find the value of K. So year 1, year 2, and then year K. So K here is our value of n. So we're going to say that A plus n minus 1, so some term in the sequence will equal 32,000. We've got to work out what is the first time it reached 32,000. So we're going to write down that 17,000 plus n minus, or K minus 1, wouldn't really matter if you use n, times the difference, which is 1,500, that equals 32,000. And then it's just a matter of trying to solve this. What I'll do is I'll take away 17,000 first of all, so K minus 1 times by 15,000, or sorry, 1,500, equals 15,000. Then we could either multiply it out, or if we divide both sides by 1,500, K minus 1 equals 10. Therefore, K equals 11. So then, we've got to calculate the total amount that Jess has earned in 20 years. So, what's happening in this question? Year 1, she's earned 17,000. Year 2, 18,500. All the way up to 10, which is going to be the first one that she doesn't, or the last one that she doesn't earn 32 grand. So that's going to be 30,500. And then 11, 12, all the way up to 20, it's going to be 32,000. So what we've got is we've got a linear, or we've got an arithmetic sequence there, and then we've got 10 years at 32,000. So that's 10 lots of 32,000, which is 320,000 for that one. And then we've got to work out the sum of this series. So the sum of that is going to be, that's going to be 10 years, so that's going to be 10 over 2 lots of 2a, so 2a is going to be 34,000, plus n minus 1, that's going to be 10 minus 1, lots of the common difference, which is 1,500. So that's going to be 5 times by 9 times 1,500 is going to be 13,500. So that's 34,000 plus 13,500, so 5 times 37,500. So if we times that by 5, what we get is 0, 0. 5 with a 2 carried over. 5 times 7 is 35, plus that's 37. 5 3s are 15, plus 3 is 18. So we've got 320,000, then we've got 187,500. And we add those together, 0,05705. So we've got £507,500. And again, that one is just saying that it's an arithmetic sequence up to a point, and then the rest of them are going to be the same value. Now, if we have a look at the one from 2014, again, it's not a huge question. So we've got in the year 2000, the shop sold 150 computers. So 2000 is the first term. 2001 is the second term. And you see that these numbers here don't match up. So just be careful, that's where a mistake can be made. So we've got A is 150. And then D, it tells us that each year 10 more computers are sold. So D equals 10. Okay, so 2007, have a look at that. That's going to be the 8th term, because notice that this digit here is always one less than this digit here. That's going to be the 8th term. So we're going to have n equals 8. So A plus n minus 1 plus D. So we're just looking for a term. We're looking for the term in 2007, so the 8th term. So what we do is we substitute our numbers into our equation there. So that's going to be 150 plus 8 minus 1 is 7 times by 10. So that's going to be 150 plus 70, which equals 220. Good job, we got the first 2 marks. Calculate the total number of computers sold from 2000 to 2013. So again, 2013. We're going to go up by 1, so that's going to be the 14th term. And it says total, so as soon as it says total, we're going to use n over 2. 2a plus n minus 1 lots of d. So that's going to be 7, because 14 divided by 2 is 7. 2 lots of a is 300, plus 14 minus 1 is 13, lots of 10. So 13 times 10 is 130, plus 300 is going to be 430, and we're timesing that by 7. 0, 2, 7 times 4 is 28, plus 2 is 3010. So that's not money, that's just the total number of computers. Okay, so 3010. Oh, sorry there. 3010 for that one. I've already done that one. So that's 5 marks. 5 marks out of the 9. So in the year 2000, the selling price of each computer was 900. Then the selling price fell by £20 each year. That 2001 was 880, and so on and so forth. In a particular year, the selling price of each computer in pounds was equal to 3 times the number of computers the shop sold in that year. By forming and solving an equation, find the year in which this occurred. Okay, so let's do that. Let's read through that last bit carefully. The selling price of each computer in pounds. And that is in a particular, so it doesn't tell you what year, but you've got to find that year. So it's going to be A plus n minus 1d, because we were looking for a certain term, so it's going to be 150 plus n minus 1 times the value of d, which is 10, and that equals, that's 3 times the number of computers, so that's going to be 3 lots of the total number of computers. So if you have a look at the total number of computers over here, so we start off, oh sorry, no, it's selling price of each computer. Sorry, let's try that again, my apologies. So in a particular year, the selling price of a computer, so A is going to be 900, that's the original price, plus n minus 1, lots of D, and D, in this case, they're going down by £20, so it's going to be times by minus 20, and that equals 3 lots of the number of computers sold. So the number of computers sold in that particular year is going to be A plus n minus 1D, so that's going to be 150 plus n plus, oh, oh, my pen went all wonky donkey then. So 150 plus, what's happened again? Plus, and sorry, I'm trying to start my pen. 150 plus n minus 1 So I am having some issues with the pen. So basically what's happened here is we've done the thing on the left equals the thing on the right. So the thing on the left is the cost of the computer, which is going down by £20 each year. And the thing on the right over here is the number of computers sold each year times by 3. So then what we do is we simply multiply out the brackets. So it's going to be 900 plus n minus 1 lots of minus 20 equals 3 lots of 150 plus n minus 1 lots of 10. And then you multiply out all the brackets and you equate it, and then you end up getting your value for n, which is increasingly hard for me to write down. But what you should get, if I just pause the video, and then if we rearrange that, we should get n equals 10, which if we have a look at the right hand side down here, we can say that if n equals 1, then that's going to be 2000. If n equals 2, that's going to equal 2001. So if n equals 10, take away 1 from the value of this, and it's going to be 2009. So that's how you do these questions.